Hello dear students, welcome back to another presentation where we are going to continue with the 2025 Northwest Regional Mock and Proposed Solutions to Pure Mathematics Paper 2. I'm called Data Ernest, and in the previous videos we had proposed solutions to question 1, question 2 and question 3. So if you haven't watched those videos yet, please go watch them and then return back to this particular presentation. Alright, we are going to start off today with question 4, a question on trigonometry, and the question reads: show that sine 2x plus sine 4x divided by 1 plus cos 2x plus cos 4x is equivalent to tan 2x. Now, notice here that we have a left hand side and we need to show that it's equal to the right hand side. The choice is yours. You are free to either take the left hand side and arrive at the right hand side, or take the right hand side and return to the left hand side. So, but to me, I find it easier to take the left hand side, simplify to arrive at the right hand side. Now, what we can see here vividly is that on the right hand side, the angle is 2x. That is a double angle. And on the left hand side, I have some angles at 2x and some angles at 4x. So since I want to decompose this into tan 2x, then I must decompose this sine 4x and cos 4x into 2x. But there is a formula for that, and that formula is called the double angle identity. And we have that sine 2x can be written as 2 sine x cos x, and cos 2x can be written as cos square x minus sine square x. We are just dividing this angle by 2. Here 2x will split to just x or 1x, and here cos 2x will decompose into x and x. So we are basically dividing the angle by 2. And in the same way, there's a formula called the Pythagorean identity, which states that cos squared x plus sine squared x is equal to 1. Then how is it going to help us? I'm going to use this and decompose sine 4x and cos 4x. That means sine 4x would be, I just copy this but divide the angle by 2. And cos 4x will be, I just copy this. What am I going to do again? Yes, you got it right. I divide this angle by 2 into 2x and then 2x. And finally, the Pythagorean identity becomes cos squared 2x plus sine squared 2x is equals to 1. So in the Pythagorean identity, when the angles are the same and I'm squaring their sine and their cosine, I must have 1. Alright, let me take all of these and substitute it into the expression on the left hand side. So in the place of sine 4x, you know what to put. Cos 4x, you know what to put. And in the place of 1, you know what to substitute. So I'll be having sine 2x. And here we had a sine 4x, which I'm going to substitute to sine 2x cos 2x. And in the same way, in the place of 1, this one that we have here, I can replace it by the Pythagorean identity, which I'm going to have cos squared 2x plus sine squared 2x. And I have cos 2x, which is this. And in the place of cos 4x, I will then simplify it into cos squared 2x minus sine squared 2x. So I substitute it there, and here is it. Now, on the numerator, I have that sine 2x is common. So I can factor out sine 2x from the numerator. And on the denominator, a lot of things are going to cancel out, because sine square x can take care and cancels out very nicely with sine square x. Then cos squared 2x is common to cos squared 2x, and when I add them both, I'm going to have 2 cos squared 2x, and I'm left with cos 2x. So let me write it down. So on the numerator, factoring out sine 2x, I'm left with 1 plus cos 2x, and on the denominator, sine squared 2x cancels out sine squared 2x. When I add cos squared 2x plus cos squared 2x, I have 2 cos squared 2x, and I'm left now with just plus cos 2x. Now, on the denominator, notice that cos 2x again is a factor. So I can factor out cos 2x. I'm left with 2 cos 2x, and cos 2x divided by cos 2x gives me 1. Now, 1 plus 2 cos 2x is exactly the same with 2 cos 2x plus 1. So they cancel out very nicely, and I'm left with sine 2x divided by cos 2x. That gives me tan 2x, which is the right hand side as required. So I have successfully shown that the left hand side is equal to the right hand side. So let us move on now to the other part of the question. And the other part of the question is this. We have been asked to hence find the general solution of this expression is equals to 1. And when you see hence on a question, it's telling us that let's use the idea that we obtained from the previous question and then solve the preceding one. So we have shown that this left hand side is equal to the right hand side, and hence let's solve this equation equals to 1. And notice that this expression that is the left hand side is the reciprocal of this expression. Reciprocal means that the numerator becomes its denominator and vice versa. So if this is a reciprocal of this, and then that means that this result as well is a reciprocal of tan 2x. So that means I can safely write that 1 divided by tan 2x, which will be this expression, is equal to 1. All right, let's put that down into writing. And I have that. Notice that the expression that we had shown is a reciprocal of this expression. And we had shown that this expression was tan 2x. So finding the reciprocal will be 1 over tan 2x. And we can equate it to 1. So I have 1 over tan 2x equals to 1. Let me cross multiply. So I'll be having tan 2x equals to 1. In order to liberate and find 2x, I need to find tan inverse of both sides. So 2x is tan inverse of 1, and tan inverse of 1 is 45 degrees. And this 45 degrees has a name called the principal value. Reason being that trigonometry functions are periodic, and it being periodic means that there are many values for which can satisfy that particular equation. So this 45 just happens to be its principal value. So to proceed, we need to write out the general solution for tan x. And by definition, the general solution for tan x is equal to c is x is equal to the principal value plus 180 degrees n. Now I have stated the general solution in degrees. So if I was solving in radians, then I will write out the same thing, but I will replace 180 degrees with pi. All right, that being said, so I will just take 45 degrees and substitute it here and write out the general solution. So x, so 2x will be equal to principal value, which is 45 degrees plus 180 degrees n. Then I can divide both sides by 2. Dividing both sides by 2, I'm going to obtain x is equals to 45 degrees divided by 2 plus 180 degrees n divided by 2, which simplifies to 90 degrees n. So we have come to the end of the first part of the question. But before we proceed, I need to emphasize that there are some mistakes that some students always do. At this point, they will just divide both sides by 2 to find the value of x and then substitute it into the principal value. No, each time you find tan inverse or cos inverse or tan inverse of that equation, the angle that you obtain is a principal value. Do not go ahead simplifying before substituting. Substitute it before you simplify. All right. Now we are going to go to the next part of the question, which we were given f of x as cos 3x minus root 3 sin 3x, and we were asked to express it in the form f of x is equals to r cos 3x plus lambda, where lambda is an acute angle, an angle between 0 and 90 degrees, and r is a positive value. Now to do that, we have been asked to write this left hand side as r cos 3x plus lambda. So this is what we have been asked to do. That let us express this as this. Now if we are writing this left hand side as a right hand side, so there are two unknowns that I have to look for. I need to find the value of r, that positive constant, and I need to find the value of lambda, that angle. But to do this, I need to recall the compound angle identity. And the compound angle identity for this particular question will state that cos A plus B is equivalent to cos A cos B minus sin A sin B. So I can just expand this. So what does that mean? It means that cos 3x plus lambda, so A takes the place of 3x and B takes the place of lambda. That is why I have cos 3x cos lambda minus sin 3x sin lambda. So I can proceed now and I write it out. So r cos 3x plus lambda is equals to, I distribute r, so r distribute and I have this term. Now, if this left hand side is equal to this right hand side here, then it can only mean that the coefficients of cos 3x and sin 3x are the same. The coefficients here means that the constant multiplying that term. Now let us write it out and see. Now the coefficient of cos 3x on the right hand side is r cos lambda, because r cos lambda is that constant multiplying cos 3x, and the coefficient of cos 3x on the left hand side is 1, because 1 is the value multiplying cos 3x. So I can form the first equation saying that r cos lambda is equals to 1. Likewise, the coefficient of sin 3x on the right hand side is r sin lambda, and the coefficient of sin 3x on the left hand side is root 3. Notice that the negative sign cancels out with each other. So I'm having the equation r sin lambda is equals to root 3. So at this point, I can go ahead and solve it. So I have to put my knowledge of algebra and trigonometry to bear in order to solve this particular simultaneous equation. So the first thing I can notice here is that in equation 2, I have a sine, equation 1, I have a cos. So if I divide equation 2 into equation 1, or equation 2 by equation 1, I'll be dividing sine lambda by cos lambda. So let me take equation 2 divided by equation 1. So I'll be having r sine lambda divided by r cos lambda is equals to root 3 divided by 1. And notice that the r cancels out, and sine lambda over cos lambda gives me tan lambda is equals to root 3. Then lambda is the tan inverse of root 3, that gives me 60 degrees. So I have the value of lambda as 60 degrees. So the next thing to look for is to find the value of r. And many students may just substitute 60 into any of these equations solve for r, which is not wrong. But bear in mind that if the angle is not a special angle, you may have to deal with decimals, which is going to reduce the accuracy of your result. So the rightful way to approach this is to put your idea of trigonometry to bear. So I'm going to take equation 1 and square it, take equation 2, square it and add it. And at the end, you are going to see why I am doing this. So squaring equation 1, I'll have r squared cos squared lambda. I add it to the square of equation 2, r squared sin squared lambda is equals to I square 1 and I square root 3. Then I'll notice that r squared is common to these two terms here. So I factor out the value of r squared, and this is the Pythagorean identity. It will always be. And this will boil down to 1. So I have r squared is equals to 1 squared plus root 3 squared. So I'm saying that when this question comes in examination, you can ignore this step and just say r squared will just be equals to the sum of the squares of the arms, the result that you have here. So r squared is equals to 1 squared plus root 3 squared. Alright, so 1 squared gives 1, root 3 squared gives 3. When I add them, I have 4. So r squared is equals to 4, and the square root of 4 gives me exactly 2. So you are going to always have your value of r as the exact value when you proceed with this method. So r is positive 2 because r is a positive value. So now I have the value of lambda and the value of r. So f of x now can be written as 2, because that is the value of r, cos 3x plus 60 degrees, the value of lambda. Now let us answer the last part of the question, and we have been asked to find the maximum value of this expression. Maximum value means the greatest value or the highest value that it can have. But we can do that because the cosine and the sine function are bounded function. That means they are bounded between two boundary values. And when you solve the value of r and you express it in this form, r, which is 2, is always the maximum value of that function. So that means because we know that cos of any value is bounded between -1 and 1. So multiply it by 2 will also bound it between -2 and 2. So I can safely write that f of x is bounded between -2 and 2, where these values are the values that we obtain for r. Okay, so we have to write down a very important mathematical equation. We have that the maximum value of what we are looking for will be equals to 1 divided by 4 plus the minimum value of this expression. The idea we are applying here is that when the value of the denominator is decreasing, the entire denominator becomes big. So if you have been asked to find the maximum value of this expression, we have to divide by the minimum value of f of x, because we want to make the denominator smaller, thereby making the entire value larger. So that's why we have 1 divided by 4 plus the minimum value of f of x. And the minimum value of f of x here is what? -2. So when I do the math and evaluate, I have half. So half is the maximum value of that expression. That goes without saying that if you were asked to find the minimum value of this expression, I'll be dividing it by the maximum value of f of x. So I'll be having 1 divided by 4 plus 2. That gives me 1/6. So I hope you have understood this explanation. Now, but if you do have any questions, please leave it in the comment section. I'm going to come up and explain it and clarify your doubt. And if you find value in this content, please do not hesitate to drop a like on this video, subscribe to my channel if you haven't already, and turn on the bell to keep notified each time I post new videos. And also, please, you can also leave motivating messages and comments that is going to remind me that I'm doing the right thing and continue with the same spirit. Thank you, and I'll see you next time.